if you want to make an engineer angry, the best method is just to go and to challenge his knowledge.
Hi, this is Adrian, and I hope you are doing great. I invite you to another interesting episode on Tactical Project Manager, a conversation with my friend Cyprien Rusu, who is a very successful engineer. The topic of our conversation is how we as project leaders can collaborate effectively with engineers. So the thing is, as project leaders, we are usually collaborating with a range of different people with different skill sets, different backgrounds. And as you have probably realized yourself, not all people are the same. There are big differences depending on what area somebody is working in, whether somebody is working in sales, marketing, purchasing, engineering. People are just very different in their beliefs, in their thinking, in their values, in their approach to work. And if we as project leaders want to collaborate effectively with those people, we need to understand what makes those people tick. How do they think? What are their values? We need to show empathy, because only then we are able to build trust and have a good working relationship. And the first group that I want to discuss here are engineers. So that is why I have invited Cyprien. He's a very successful engineer, and he's also one of the smartest people I know. He speaks, I think, 10 languages, including Chinese, Japanese, Korean, fluently. And Cyprien will help us better understand what engineers are like and how they approach their work. And some of the specific questions we discuss are, for example, what process does an engineer follow to go from an idea to a product? How can we as project leaders best allocate engineering resources in a project? But also, how can we connect with engineers on a personal level in order to build that trust that is so important to have a successful collaboration and have a successful project? So I hope you liked this discussion, and make sure you leave a comment below the video if you enjoyed this video.
So, Cyprien, welcome for coming onto this call and sharing your insights about what engineers are like and how we as project leaders can work effectively with engineers of any kind. And I think you are the exemplary engineer in a good way. Tell us, who is Cyprien Rusu and what do you do? What's your background? And also, what are you doing with your business, Fair for All?
Sure. First of all, thank you very much for inviting me. So this is the second time we have this kind of interview. So, and we had many discussions in between, of course. So, but for those who don't know me, so my name is Cyprien Rusu. So and I'll talk a bit about my background, so you understand why I might be qualified to talk about engineers. My education is that I am, well, first of all, I'm French. So even if I speak English rather fluently, I'm French. I am a generalist engineer. So I've done a generalist engineer diploma in the École Centrale of Lille in France. And then I've done a specialization in geotechnical engineering in the Tsinghua University in China, in Beijing. After that, I've worked mainly in the domain of engineering simulation software and R&D, so research and development, in South Korea and in China. So I'm currently living in China, and wow. That's why it's all dark outside.
We can't see it.
And I'm not only an engineer, I've done a lot of other kind of tasks. So I've done a lot of technical sales, business, partnership, contracts. I have managed small teams, and I've done some marketing. I've done a lot of
That's amazing. And let me ask you, because you mentioned you have a generalist engineering degree. I think that's quite unique, because the way I used to think about engineering, there's mechanical engineering, electrical engineering, and probably many other fields. So is that common, or how are most engineers are trained versus how you were trained?
I think it's something quite special in France, the generalist engineer kind of way of education. So they are generally, engineers are either very specialized in one domain, or in France, we have this kind of concept that the generalist engineer should know, let's say, a bit about every types of engineering, and the purpose being to not necessarily to do everything himself, but being more like in a manager position where you manage other engineers, a bit like a project manager or product manager,
Yes.
where you can really not only manage without understanding, but having an engineering background, you can also understand and go deep or specialize if you want into one type of engineering. So it's very flexible, and the education of generalist engineer is very packed. So we really study everything from mechanical, fluid, chemical,
Right.
computers, everything you can do in engineering. We have it in France. And in other country, there's not really equivalent to that. But I've heard that industrial engineer is close.
Yes.
So someone who is industrial engineer will have also some kind of wide exposure to various domains.
So, but as we talk about engineers, we have to keep in mind that there are really many people are actually trained in a very specific niche, right? For a very specific field, whether it's mechanical or whatever. So, and this will be mostly the type of people we will be, or we as project leaders will be working with.
Now I'm working in a startup. So I'm still in the domain of simulation software. So it's a American startup called OnScale, which is, and I'm the director of engineering Asia for them. So I'm, doing a lot of engineering still and a lot of other stuff at the same time. So, and as you mentioned at the beginning, I have also a lot of other, let's say, secondary activities. I have a blog called FEA for All. So for those who don't know, FEA means finite element analysis, and it's a method used for simulating virtual models in 3D on the computer, and basically reproducing physical testing, but inside the computers.
When we talk about working with engineers, so I have worked in industrial companies, and I have worked with engineers, and I always felt it was like, this is a very unique kind of people. And whenever I walked into some engineering department, I could feel it, like this is a very different world, which was strange because I have a computer science background, so it's also a technical background, but still engineering is very different. The people, the terminology, maybe the values, the beliefs, all of that, which we are going to talk about. Maybe to get started, how does an engineer typically work? What is the typical process of their work? How do they go from an idea to a product or whatever they are working on?
Engineers first, there are so many different kind of engineers. So that's the first thing.
Right.
Engineering is a kind of a category of, professions. Someone who is an engineer do this kind of thing. But there are different kind of people who are engineers, because engineers are people also. And they are various kind of specialization industry. And so I'm going to try, to reduce, and put a certain kind of profile on one type of engineers, and tell you what engineers are really doing and thinking, because this is what, you need to understand as a project manager. And the most simple definition I could find about what an engineer is doing is that engineers are building stuff. So engineers are people who build things, create systems. And, by things, it's generally physical, models, systems. And it can be basically anything in this world. There are so many systems around us that, we are. So our computer is a system with many parts. The car you drive is a system. The plane we go in is a system built by engineers. The building you're living in is also a kind of system built by engineer. Even, a very simple object like a table can be a system built by an engineer,
how would you define a system for the non-engineers?
I would say that a system is something that can be broken down into an assembly of parts which work together to achieve a certain type of goal or function. For example, you can think about the purpose of the car is to drive you from point A to point B. And it is composed of the seats, the wheel, all the motor, all the kind of parts which are inside the car. You can basically break down the car into thousands of different parts. The whole car system is composed of all those parts. And I would say that the purpose of an engineer is first to understand the system. So understand how things work is very, very important for engineers. Mm-hmm. So they have to be, if he's an automotive engineer, he has to be able to break down the car and know how all the parts are working together and how they are interacting, how changing one part will impact the others. This is part of the common engineering knowledge for automotive engineers. And that's also why it's important to understand there's various kinds of engineers, because an engineer which is a structural engineer, he will understand everything about buildings and structure and materials which are making the buildings, but he will not understand how a car works, not necessarily,
sure. Yes.
Right? So various kinds of engineers, but I think all engineers value knowledge. Probably the most important thing for engineer is being knowledgeable about things. And so the fact that you're able to learn quickly how a system works and you're able to understand it, and really, like I told you, what engineers do are building things. Right. So the next step is really to be able to create a system or modify a system or improve a system or optimize a system. And that's generally what engineers do, one of those four things: build, create, optimize, change.
And you mentioned, for example, simulations as one part of the step. Yeah. If we take an example from like building some custom machinery, what would be the high-level project stages or the steps that an engineer would go through that I would have in my team?
Very high level. So first of all, like I said, well, the first step is always to understand the system. So if this is a certain type of machinery, the engineer should be an expert in this kind of system and understand how the system basically works. So that's the first thing. Now, the second thing is, in your project, what do you really want to do with this machinery? So what is the goal of the work, basically? Is it to, do you already have a certain machine that is already working, but, it has a problem in some way and it has to be improved or optimized? Or do you have a machine which is broken and basically has to be repaired? Do you have nothing at all and you have to create from scratch a new machine that doesn't exist yet? So once you have one of those three things, you can define the goal of the work of the engineer. So if, let's take an example, the goal is to build a system from scratch. So there is no machine at all. The engineer will have to first to understand what kind of function this system will have to perform. What is the output which goes out of the machinery, and what is the input that you put in, and what kind of efficiency do you want out of this machinery? So should it be fast as the first condition? Should it be safe as the first condition, or should it be
cost efficient or cheap? Exactly.
So once you have the goal, the objective, the engineer knows what kind of the machinery is, then he has to define clearly what is the problem and what he will have to work on.
So that means there are lots of also discussions with the client needed, how it should be done ideally to put the engineer together with the customer.
Yeah, obviously, because the goal of the system is defined by the customer. So, if this is a system built for the customer expects something out of it, right? So if it's a machinery to put in his factory, maybe he wants his factory to go faster, so he goes a machine which is faster than the previous one. Or if he wants a machine which will be safer because the previous one were exploding, so then he will need to build something which is safer. So it's different on the goal. And the customer will have, of course, a lot of requirements. For example, he doesn't want to spend a certain amount on the materials, or which will impact the quality, or all kind of stuff.
And maybe these requirements, there can be conflicts. You may want to have a very reliable system, but you're not willing to to spend more than a certain amount, right? So lesson is here really to be clear about what problem we are trying to solve. And it may not be as obvious as it feels to us who are just doing the management side of the project, right? But there are more questions that have to be asked by the engineers. So once we have fixed the goal and what we are trying to achieve, like what would be the next step for the engineer?
Yeah, so exactly. So that's really the first step for the engineer, the goal, and being clear about what has to be achieved. The next step is really to make, let's say, you have to make a strategy to build the system, right? So if you're building from scratch, so you have to make a plan which is very clear about what kind of part you will have to build first, in which order, and which part, how you will build it, with which kind of material, using which kind of tools. So you have to make a plan about how you will create this system. And this also comes with experience, of course, because if you have a lot of experience, you know what kind of part takes how much time, and which kind of tool you can be most efficient to do with kind of thing. So you have this plan, you have this strategy on how to build it, and then you really have to start the real work. And the real work for engineer is to actually build a system. So you have to, and generally this works with iterations. You don't find the perfect parts or the perfect shape or anything you want from the first try. It's never worked like that. You have to build the prototype, and you have to test it thoroughly with various kind of tests that will confirm or not that you've reached the goal that you have set yourself.
You mentioned the need to create a plan. So what would this involve? I mean, probably designs, but also what other kinds of maybe documents do you typically create in the process?
Well, that depends on the product, the company. If it's a startup, it can be very fuzzy.
Right.
You can design it as you want, and you're very free to do what you want to, as long as you don't have supervision. But if you're in a big company, that is very experienced on this kind of product for like 50 years or something, you just cannot be that fast. You will be more like a cog working on one part of the system and improving some of the things. So it really depends on the company, the industry, and the size of what you're doing and how innovative it is.
So then you go through these iterations, and how do you, as an engineer, validate then the functionality of your prototype or model, whatever?
You validate using testing. So you test that it works or not, following your criteria. So basically, generally, if you build a mechanical system, for example, that your system should withhold a certain amount of loading inside it or outside it, or on some part of it. And you can test that either physically in laboratory. You go there with your prototype and you test it, or you can do it on the computer. And this is what I'm teaching on my blog. So now this is why simulation and engineering simulation is so important, because it really allows engineers to take, instead of going for the physical testing, which is costly and take a lot of time, they can just build the model in 3D inside the computer and testing it inside the computer.
So now we have simulated, or we have tested the prototype. How do we move on in the project?
So if the prototype is tested, and if it is validated and the objectives are reached, then I would say that the job of the engineers is almost over. Then it's you have to build a real product after that, right? You have to go from prototype to building the actual product, and then the product goes to the company, to other teams who will start to market it and sell it, and or do whatever done with the product. So then it's not the job of the engineer anymore. Engineer is really focused on building it and making sure that it works and improving it. And if there's problem into the product, then the engineers has to come back and study what is the problem and correct the problem.
How can we wisely allocate our engineering resources? Like, where should we where should we put all the brain power and the experience in, and what are maybe some tasks that we can give to first time to beginner engineers, like who are just new on the job, or maybe even students, I don't know, university students, and still of course deliver a successful product and project.
Yeah, of course. Obviously there are engineers who are junior and are just starting, and there are engineers who are more experienced now, and of course there's engineers who are good and those who are bad. But I would say that even a junior engineer has a lot of baggage in terms of physics, mathematics, theory, especially if they just go out of engineering school. It's a very heavy education. So even if your junior engineer will know a lot, but probably not be so much experience in practice on actual product or on the building the actual stuff, but I believe he will be much more knowledgeable in how the system works in theory, or how the mathematics of the system. So generally, I think young engineers must be advised by more expert engineers all the time, not put into too big projects from the start by themselves without any kind of support. You must have at least one expert engineer who knows about the system for a long time and knows the potential problems and everything. And then he can have under his management some junior engineers who are maybe will do simpler but work that can be done by more easily without necessarily having the experience. So if they lack some knowledge about some part of the system or how it works, they can ask the more experienced engineer, and then they can discuss and understand how it works together. So you need to have a mentor, I think, if you are an engineer inside a company. And
but that mentor doesn't have to be around you all the time or in every meeting. But would you say the early stages of the requirements gathering, understanding the problem, is that something also a junior could do, or would you put there more the experienced, the senior level engineers?
So I would say it depends on the people, right? If good engineers are people who can listen very closely to what the customer wants and his requirements, and be able to ask the right questions also, and at the same time staying humble, and this is something probably young engineer can do also. But it's true that sometimes some of them lack the global vision for really understanding what a customer needs or wants, if they don't have a direct experience in the same industry that the customer.
So let's move from the more like the field itself and the processes to more the soft skills level. So that the stereotype of an engineer is like they're more introverted, more work with numbers on the computer, more on their own. But from what you described, engineering is really also a collaborative discipline, which requires you to talk to the customer. From what you have observed managing engineers, is that something that comes easily to engineers?
So that's what I would say. It's one of the weakness of the young engineer, or maybe in the engineer in general, is that as an engineer, you kind of, instead of talking to people, you're mainly talking to machines. So you have to understand how system works, how machines works, and it's fascinating to understand how a computer works and how all those systems are working together. And you sometimes forget that humans are not working in the same way than a computer, right?
Absolutely, yes. So,
you would like to have interaction as efficient with a computer than you would have with a human, but it just doesn't work like that in the real world, because humans have emotions, and it's basically very, very different. So engineers become engineers. Why? Because they like to learn, they like knowledge, they like to understand how things work. But it's very often you do that by going deep on a subject and becoming expert on something. And how do you become expert? Well, by reading a lot of books,
exactly, on your
understanding a lot
own.
of things,
Yes.
Calculating a lot of stuff. And, and after you do that for a long time, you do your PhD, you like that into books and everything. Then you have to work in a company and start to discover again the real world and start to talk to people who are not engineers and don't understand what you want to tell them. And that can be confusing for young engineers. So young engineers who are just out of university understand the theory of the systems, and they sometimes, if you lack the skills of talking with others, of empathy, or communicating, this kind of thing, you can very easily appear or as someone who is either rude or someone who lack a lot of soft skills is generally can be horrible, because it's not because of his faults necessarily,
exactly,
but he just don't understand how you communicate,
right,
with people.
Yeah.
So, but I would say that to become a good and even outstanding engineer, you do have to take a lot of time to understand how that works. You have to focus on your soft skills as
Okay.
an engineer and learn how to communicate with people, how to understand people, how to simplify all the complexity in your engineering life into some very simple concept that everyone can relate to. And
so being able to express your knowledge and your questions in a clear way.
Yeah, because that's also, engineers tend to speak in jargon with other engineers.
Yeah, exactly.
And it's both some kind of pride because, they understand each other, and they feel different from the other people because they know this and they know that. And one of the real thing about engineers is that they're very proud about their knowledge and what they know. And if you're an expert on a specific type of stuff, you're very, very proud to know all of this much more than anyone else. And if you want to make an engineer angry, the best method is just to go and to challenge his knowledge and no, you don't know this. I know that better than you. Yeah. Especially if you're not an expert on this and you tell an engineer, I know that better than you.
Right.
It's the best way to make it just leave. And if you want to get more friendly, more close to an engineer, I would say.
Yeah, that would be my next question.
Yeah, like with every people, I think the most important is to build trust in between each other. And to build trust, first you have to be honest. So never, lie about what you know or lie about what you can do or about, the real goal of the project or, always be very honest with engineers and with other people as well, right?
Yes, yes. Let's say I'm a project manager in the same company as you, and I'm working with you, about to work with you in our first project, and it's our first meeting. What would be some good, topics to start a conversation with you to, for building trust?
Well, I would say if you don't know the engineer, I think engineers are always happy to talk about their education, their knowledge, their specialty, what kind of system or tools they use and they like. And, so it's always good to ask questions about, what kind of education you did, where did you graduate, or, if it's young engineers, if, he's already a lot of experience, maybe, you have to change a bit your questions, but
right.
What did you study for your PhD or a master thesis? And try to be really interested, genuinely interested in what he says, not just listen just to find some clues of how you can manipulate him or something. This is the worst you can do. I think that to really build trust, you have to be really interested into what people say, right? And try to understand this, basically what he knows, what he likes, and generally if he's an engineer, it will be related to engineering, building. What do you like? What kind of system you like in your current environment? What kind of computer you're using? If it's a software engineer, you can talk about computers. Do you like Linux or do you like Windows computer? Or What do
Okay.
you think about Mac computer compared to Windows?
So this
or,
would get an engineer to speak and to open up.
Oh yeah, I don't know an engineer which is not close to to computers who do not like to talk about his computer or
Right,
his
right.
software or
One more question is like, because we are as project leaders, we don't have the subject matter knowledge of an engineer, of course, but it's of course helpful. You mentioned the jargon that's being used in engineering. Would it be also appropriate like to ask them about more to get a better understanding about their field and what is this, the simulation you're doing? Tell me a bit more. Would this be also something that would get the engineer into
yeah,
a
of course.
happy mode where we would talk?
Yeah, I would think ask as many questions as you can. But there is a but. It's a double-edged sword. You have to be clever and ask intelligent questions. Don't be the guy who asks questions just to ask questions or about things which are so simple that you can find it on Google. And this really shows that you're not genuinely interested into asking questions.
You're just
asking
faking
for
it.
asking. Or that you're too lazy to search by yourself and just you want others to do your work. So if this is a very specialized question that it would take you hours to find an answer or things like that, then it of course you can ask or not even hours, but just don't ask things that would take 5 minutes to check, like facts or stuff like this. I think it's fine to ask questions about everything. Engineers like a lot of questions.
Great. These are really helpful tips for building that trust that's so immensely important in a successful project. One more tip from my side to build trust is also with engineers is to match their style. So as you see, I have matching your style. I'm unlike on the other days, I'm wearing a shirt and a pullover. So that's also something. If we appreciate people who look similar and who talk similar language, similar style. Super helpful. Super. Any last tips you want to give to project leaders on making and building an effective team with engineers?
Well, I really have a lot of things to say. So let me think if there are a few things. Yeah, maybe I have a few things I actually know because you asked me to prepare, so I listed a few stuff. And
perfect.
Maybe what we didn't really talk about are this question is maybe what potential problems that can come between leaders and engineers.
Yes.
And in projects, what kind of stuff that can happen that can cause to have a bad relation between those two. And I can think of a few things like that. And it's not everything, it's just part of what I experienced. So, for example, one of them is, like I told you, engineer realistic goals and systems that can be built realistically in a certain time frame and with the tools that they are familiar. There's a big difference with those leaders who have this kind of big visions and want to create challenging goals, and they who don't really have a very narrow idea of what they want to do, but they kind of put together some buzzwords to create stuff. I think what I'm talking about. Those leaders in big companies who want to be interesting by making those new fancy projects, and they say, okay, we have this big vision, we want to do this kind of project and everything. And because they're not very specific and realistic, they leave a lot of door open, and they're not very, how to say, it's very difficult for an engineer to build a system or accomplish a task when the task is not defined,
not clearly defined.
You don't know what you have to do exactly. You don't know which element you have to put together. You don't know the actual goal, and sometimes engineers are given tasks like that. Well, build me this kind of AI system that can do this or that can do that. And, the engineer had just, but, there's a lot of AI types of system that I can build who can do a lot of things. So, and 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 the thing is that about these kind of I would say bad project, it's basically bad management, right?
Yeah.
They come up with those ideas is during the project, they add up a lot of new stuff to add or change, or
oh my
there's
God,
a lot
yes.
of rework during the project.
Right.
And the engineers who have started to work on something, sometimes they discover that they have to work on something totally different. They have to change everything they've been doing. And this is just horrible when you are an engineer, when you're working something which is not clear and where there are moving parts all the time.
Yeah.
So I would say this is one of the difficulties that can cause problems in a project with engineers. You have to be very specific and try to be as thorough at the beginning of the project about the requirements and make sure they don't change too much during the project. And also what is also annoying is those managers who are, we were kind of talking about them, but who think they know everything and they are micromanaging all the way everything that has to be done by engineers. So they don't know how it works, but they think they do. And they just, follow step by step what is done, and they want to change everything. And
but they have no clue, actually. Yeah.
Yeah, they have no clue. And generally, so it's even worse when they think that they have to give an advice just to show that they are the guy in power.
Right. Instead, they could just admit they don't know, and they will check with the engineer. Right. Yeah.
Yeah, and generally, they stay on the cosmetic level of things because they don't understand how the system works. So they're always changing the color, changing the appearance, the number of buttons, and stuff like this, and making everyone angry and and basically and also what something I didn't mention, but another thing engineers really hate is to destroy what they have built,
where they put their heart into, and then
because
change
all
happens.
the heart of the soul of an engineer is to build something, and when you are already a very long step into the project, you've spent so many hours to think through this problem and to make this happen, and someone tells you, well, we just cancel the project, and you're like, oh my God, I just want to resign from this company.
And this does happen a lot, right? In reality.
And the company or the managers, they say, well, it's nothing, we just canceled. You can go on another project, do something else. And then also at the same time, this is why a lot of engineers are becoming very, very angry in themselves about the company, about how things work, about the politics, and
they
stuff.
eventually may leave, right? They may quit.
Obviously, if this is really something that they put all their hearts to build and they were proud of it, and suddenly it disappears, it hurts.
Absolutely.
It's like losing a loved one for an engineer to lose, or lose the system you have built. It's a catastrophe. That's
not something we want to ever face. But I think with your great tips, we as project leaders, we are well equipped to build up a good relationship with our engineers. A lot of very specific advice, like asking about their education. So I think that's something we can implement right away. Thank you so much, Cyprien, for coming on this call. And I will link your website also below the video, and the interview that you have done with me. Let's meet for another call sometime and talk about
that's what I was about
topic.
to say. If you have more questions and you want to dive deeper in some specific topics, why not? I'm always glad to talk with you and to talk about these topics, because I'm really passionate about engineering and about everything that relates to it. So
that definitely comes across.
Teach everyone the greatness of being an engineer.
Perfect. I think we are now really able to see the world from the eyes of an engineer, and that's what I wanted this call to help with. So thanks again. Thank you so much, and have a great day, Cyprien.
You too. Thank you very much.